Hello, this is a chair I designed using Fusion 360, a computer-aided design software. I was pretty proud of this chair until I tested its strength. In the quest to design a stronger chair, I explored generative design, a technology that uses machine learning to help engineers 3D model objects. Oh, and topology optimization as well. To share my findings, I interviewed Claire, a fellow senior high schooler.
I don't know what any of those words mean.
And probably neither do you. So let's get into it.
Topology optimization is used when you want to reduce the weight of a component or a part, but you still want it to retain its strength properties. So this is an example of a part or component that you might want to reduce the weight of. This is like a bracket. It's like an arm. So if you imagine two poles or two rods going through these holes, and there's force being applied over there. If there's a force being applied at the blue arrow, you can see the stress being applied on the part. So the red is where there's more stress, and the blue is where there's less stress. If you look at this topology, so if you look at what topology optimization did, it removed the material with the dark blue, and it kept the material at the red. So this part is still strong enough to withstand the force, but it's a lot lighter. That's what topology optimization is. Now I want to introduce you to generative design, which is a technology that's based off of topology optimization, but it incorporates machine learning and artificial intelligence. So this is a chair. It's like a very typical design that a human would make, right? Straight legs, square. This fillet helps improve the strength of this joint, but this is pretty standard. It's a pretty standard chair.
It's a human chair.
Yeah.
Let's compare them to the chairs that
This
we're sitting
is
on.
a chair that generative design
Whoa.
made. So as opposed to topology optimization, where a human designs a part first, in generative design, a human does not even have to design a part in the beginning. The entire process is done by the computer. All you have to do is define the geometries that you want the computer to keep. So in this case, this top part is just this part. And I told the computer that I want the legs of the chair to make contact with the ground at these 4 points here. And the computer generates all the geometries in the middle. And the way it generates something like this is by first randomly generating legs.
Mm-hmm.
Okay, so this is the first iteration that the computer made. It just randomized many of the variables.
Okay.
Because in the beginning, it doesn't know which legs are stronger than others, doesn't know which geometries are better. Then, after each iteration, it stress tests the legs, like what I showed you with topology optimization. And it removes some material that maybe the part doesn't need, and it also adds material to parts that are under a lot of stress and need more reinforcement. So after many iterations, it transforms into the part that I just showed you. So this one went through 9 iterations. However, one of the most defining and unique characteristics of generative design is that it doesn't do this just one time. It doesn't just go through this process one time. It goes through this process tens, hundreds, and thousands of times with different randomly generated legs. At the end of the process, it takes hundreds and thousands of different results and combines them into a select few that are better than the other. Another factor that differentiates generative design from topology optimization is that generative design can take into account manufacturing constraints. So sometimes parts generated by topology optimization isn't physically possible to make in the real world. So with generative design, you can select different materials, different manufacturing methods like 3D printing or milling. and that just makes the manufacturing process, the design and manufacturing process, a lot easier and streamlined.
So what you're saying is that computers are better than humans in every possible way. In this specific instance.
Let me show you. Well, generative design currently is still just a tool that human designers use, and it often makes a lot of mistakes, like this one. When I told the computer to make some legs that are really strong, it just went, oh, I'll just make the entire thing a cube. That's the strongest design.
I mean, it's not wrong.
Yeah.
You can sit on a cube. Can you give examples?
It's used a lot in aerospace engineering. Since weight is a very important factor in airplanes, there's a lot of internal structure on airplanes that have been created with generative design. I think Airbus uses a lot of generative design parts.
I then interviewed Henry, who has a PhD in mechanical engineering, to hear his thoughts on this new technology. Yeah, I think generative design can only, like, they can't make anything that moves. It can't interact with other parts. It can't take that into account. So it's really only useful for making like a strong part with not a lot of mass.
I see.
You can't add like gears inside and have it understand that it's rotating,
Right.
like that. Yeah.
So it does have its limitations, what it can do.
Mm-hmm.
Yeah. So basically, this is like a so-called finite element modeling. So then, based on the model, it calculates, the stress distribution in the structure, and then just carve out the low stress areas. It's useful, but to a lot of people with a lot of experience, they may not say, I already know this stuff.
Like engineers already have a lot of intuition about design.
That's right. They already have the intuition. Yeah. And reducing weight, say from 200 pounds to 100 pounds is very helpful. But I don't need somebody to tell me, from 100 pounds, how do I reduce to 90 pounds? Unless I'm making an airplane that cares about 10 pounds. Normal, like for other applications, they don't care less.
Right.
90 pounds versus 100 pounds, they both okay. But as long as, and from 200 pounds, say to 100 pounds, they basically can kind of count on their experience to carve out the material they don't want. Yeah. I think this generative design thing, they need to, I was hoping, like, say, if you want to do certain function, then you say you have some idea, you want to design something to perform certain function, but you just don't have the exact details how to do it elegantly. Then if a software can propose, hey, you can try this, maybe try this, that actually would be something very, very useful.
Unfortunately, that's all we have time for today. If you want to watch some behind the scenes or additional content, including me stress testing the generative design legs, an interview with my little brother, 3D printing time lapses, or perhaps even some ASMR content, I'll be uploading them to this channel in the next few days, so stay tuned.